Hello students, in this video we will be discussing about mass number and atomic number of the element or atom, and also some important terms which are related to atoms. Okay, the first term is mass number. As we can see here, the mass number, we have already discussed in the previous video that if there is an element X, we can represent the mass number of that element as A, which is written on the upper side, and the atomic number as Z, which is written on the lower side. And this can be written in this format, or it can be also written in this format. Z and A is written here, right? Both are correct, but the mass number should be, which is represented in the form of A, should be on the upper side, whereas the atomic number, which is represented in the form of Z, should be on the lower side. Okay, X is the element here. So now coming to the point, what is mass number? We are telling that this A is mass number. Okay, but what is that? Mass number is nothing but it is the sum of the number of nucleons. So what are nucleons? Nucleons are the substances which are present inside the nucleus, right? So slowly we're going to learn what is nucleus and all in further videos, but we have already learnt in 9th class that if there is an atom, there is a heavily charged particle which is present inside or exactly in between, in the mid of the atom, which is referred as nucleus, and further it is surrounded by some number of electrons which are rotating in their respective orbits, right? So the nucleus which you are able to see here, which is in the mid of the atom, is actually contains protons and also neutrons. In the previous videos we have already discussed that there are many subatomic particles of atom, out of which protons, electrons and neutrons are the foremost, the most important ones. So among these three, the protons and neutrons belong, or their home is at nucleus, right? So because both are heavier compared to electrons, the mass of the nucleus also becomes heavier. Okay, now the point is, we are discussing about mass number. Mass number is nothing but A is nothing but number of protons plus number of neutrons. Together they are called as nucleons because they stay inside the nucleus. Okay, coming to atomic number. What is atomic number? Atomic number, which is represented as Z, is the number of protons present in the nucleus. Okay, it is just only the number of protons. Okay, so if we are taking a neutral atom, neutral atom means what? The positive charge in the atom is exactly equal to the negative charge on the atom. Then only the positive charge is able to cancel out the negative charge and the whole atom is becoming a neutral ones, right? Now the point is, if there is a neutral atom, that means what? The positive charge, the number of protons which you have inside the atom, will be equal to the number of electrons which you have inside the atom, right? For neutral atom, number of protons is equal to number of electrons. For neutral atom, you can say the atomic number is equal to number of protons, or you can say it is equal to also number of electrons, only for a neutral atom. But if you are coming for a charged atom, if the atom is charged, charge means what? It can be of positive charge, it can be of negative charge, isn't it? Suppose I have an atom which is positive charge, example Na plus. This atom sodium has got positive charge +1. That means what? It has lost one electron. It has lost one electron. I can write this in the form of sodium is giving Na plus plus 1 electron, right? So this is positive charge means what? It is lost electron. That means what? The number of electrons present in this will be it's total number of protons, which is your atomic number, जितना होना चाहिए, minus charge. Charge means what? Which charge? Positive charge. जितना positive charge होगा उतने electrons lose किया है, इसलिए we are reducing from Z. If we are having, suppose, another element with negative charge, Cl minus, suppose, right? If you want to calculate total number of electrons, the number of electrons will be how much? Minus means what? Minus means it has acquired an electron from another element. It has acquired an electron from other element. एक electron extra आ गया है. So क्या करेंगे? Number of electrons will be equal to जो आपका पहले से नंबर ऑफ इलेक्ट्रॉन्स था या नंबर ऑफ प्रोटॉन्स था न्यूट्रल एटम में, जो कि जेड प्लस यहाँ पे एक इलेक्ट्रॉन बाहर से आया है इसलिए प्लस 1. सो क्लोरीन का जेड एटॉमिक नंबर कितना होता है? क्लोरीन हैज एटॉमिक नंबर ऑफ 17. So therefore 17 plus 1 will is equal to 18 will be your total number of electrons present in Cl minus. Similarly for Na plus, total number of electrons will be how much? Sodium's atomic number is 11. So number of electrons will be, atomic number is 11 minus 1 positive charge, है ना? So because 1 positive charge, the overall charge will be 10. In this way we can calculate number of electrons for charged atom. Okay, but for neutral atom, number of protons is equal to number of electrons. Okay, yes, example is given chlorine 35 and 17. नीचे जो number लिखा गया है that will give you number of protons. This is neutral, ऊपर में कोई charge नहीं है, because this is neutral, you can say that number of protons will be equal to 17 and number of electrons also will be equal to 17. नंबर ऑफ न्यूट्रॉन्स कितने होंगे? आपको पता है मास नंबर 35 जो है, 35 इज अ मिक्सचर ऑफ नंबर ऑफ प्रोटॉन्स प्लस न्यूट्रॉन्स. सो आपको न्यूट्रॉन्स चाहिए तो आप क्या करेंगे? 35 माइनस प्रोटॉन्स करेंगे. प्रोटॉन्स कितने हैं यहाँ पे? 17 है. कहाँ से पता चला? एटॉमिक नंबर से पता चला. सो 35 माइनस 17 विल गिव यू 18, isn't it? So this will give you total number of neutrons. In this way we can calculate number of neutrons, protons and electrons. Okay, let's go further. Next term, very important term, isotopes. What are isotopes? Actually this term was framed by scientist named Sodi, and he said they are the atoms of a given element which have the same atomic number but different mass number. Atomic number same hoga Z but different mass number A. Atomic number is same but different mass number. Just like we have many examples. Just like we have, you might be familiar with hydrogens, isotopes. One is your protium, one is deuterium, and another is tritium. You can see here the atomic number is same 1, 1 and 1, but the mass number is changing 1, 2 and 3, isn't it? So atomic number is same but mass number is changing. In this case, these three substances are referred as, or these three atoms are related by the name called as isotopes. Okay, so here we can see what happens is isotopes have same chemical property but different physical property. Why? Because the number of protons is same but the number of neutrons is changing. The number of neutrons will decide the physical property, just like weight. Now more the number of neutrons, more is your weight. Just like you can see here, number of neutrons is 0, number of neutrons is 1, and here number of neutrons is 2. So more is the number of neutrons, more will be your weight, isn't it? So that will change your physical property, but your chemical property is same because all of them belong to similar type of atom called as hydrogen. So therefore the physical property is different but chemical property is same, the chemical nature is same. The reaction in which hydrogen reacts, in the same reaction deuterium can also react, protium reacts. In the same reaction deuterium also reacts, also tritium can also react. Okay, in this way physical property is different but chemical property is same. Okay, and isotopes do not have the same value of E by M, number of electrons by mass, or charge by mass, you can say. Why? Because you know that mass varies. Why mass is varying? Because number of neutrons are varying. Because number of neutrons are varying, mass is varying. So therefore charge by mass ratio also is not same. Okay, there is another set of isotopes for carbon, 6C12, 6C13, 6C14, and among these three this is actually called as a radioactive isotope. Radioactive isotope is that isotope which is very unstable in nature, and when put freely it releases some number of rays in the atmosphere like alpha, beta and gamma rays. Okay, the next term is isobars. Isobars was framed by this word is framed by the scientist named Aston, and these are the atoms of different elements which have the same mass number but different atomic number. This is exactly opposite of isotopes. वहाँ पे आपका atomic number Z was same. In the previous case Z was same but A was varying. But here in this case Z is different, atomic number is different, but your mass number is same. Okay, we have examples like 1H3 tritium, just now we have discussed, and 2He3. Okay, so this you can see here it is 1, here it is 2. Atomic number is different, but mass number is same here, 3 and 3. Similarly, we have potassium and calcium, 40 40, same mass number but different atomic numbers, 19 and 20. So from this you can calculate this number of protons and electrons. Now, as you all know that for this example, you all know this, but still I am again telling this, 19 and 40. This means what? 19 refers to number of protons is equal to number of electrons is equal to 19, and you know 40 will be equal to number of protons plus number of neutrons. If you want to calculate number of neutrons, this will be 40 minus number of protons. Number of protons already you have got 19, so 40 minus 19 which will give you 21. So number of neutrons for this is 21, है ना? So ऐसे करना है, right? Then we have another term called as isodiaphers. Okay, and what does this mean? That they are the atoms of different element which have the same difference of, क्या है यहाँ पे, same difference of number of protons and neutrons. जिसका number of neutrons and protons का difference same है, they are referred as isodiaphers. Example you can see here very clearly. The example is here boron, atomic number कितना है 5, mass number कितना है 11. कार्बन का एक आइसोटोप यहाँ पे 6 and 13. If you want to calculate the difference of the number of neutrons and protons, means what? Number of neutrons minus number of protons आपको calculate करना है. तो पहले इसमें निकाल दीजिए. 5 is what? Number of protons. And अगर 11 है तो number of neutrons कितने होंगे? 6 होंगे. Right? So difference is how much? 6 minus 5 is equal to 1. So in this case also you can see 6 and 13. तो number of protons कितने हैं? 6. Number of neutrons कितने हैं? 13. Sorry, 7. Number of neutrons कितने हैं? 7. Because number of protons and neutrons मिलके mass number होता है ना. So ये 6 होगा तो ये obviously 7 होगा. Difference कितना होगा? 7 minus 6 is equal to 1. So difference जो है same है, 1 and 1. In this case 1 and 1. In this case 1 and 1. यहाँ पे और एक difference है. I mean और एक example है. Nitrogen 715 and fluorine 919. ठीक है? So this is another important term called as isodiaphers. So you need to remember these examples. Okay, next isotones or isoneutronic species or isotonic, 3 different names but related to same thing. Isoneutronic species, as the name implies, same number of neutrons, same number of neutrons. The atoms which constitutes same number of neutrons can be called as isotones. Okay, example tritium 1s3 and helium. In this we can see the number of neutrons here n is equal to 2, here also n is equal to 2. So therefore it is referred as isotones. Here also you can see number n is equal to 20 and here also n is equal to 20. Calcium and potassium. है ना? This is also best example. Next we have isosters. These are the molecules which have the same number of atoms and electrons. ऐसे molecules, molecules means what? Group of atoms. Molecules means what? Group of atoms. तो ये ऐसे molecules हैं जिसमें आपका group of atoms and electrons भी same है, atoms भी same है, number of atoms भी same है and electrons भी same है. Okay, example we have CO2 and N2. number of atoms कितने हैं? कार्बन का एक एटम, ऑक्सीजन के 2 एटम, टोटल नंबर ऑफ एटम्स 3. N2 का नंबर ऑफ एटम्स कितने हैं? नाइट्रोजन का 2, ऑक्सीजन के टोटल कितने हैं? 3. सो आपका नंबर ऑफ एटम्स सेम हो गया, 3 and 3. Coming to electrons, if you see, if you want to calculate number of electrons, you can calculate easily through atomic number. कार्बन का एटम नंबर कितना है? 6. तो नंबर ऑफ इलेक्ट्रॉन्स कितना है कार्बन में? 6. वैसे ऑक्सीजन का एटम नंबर कितना है? 8. नंबर ऑफ इलेक्ट्रॉन्स कितना है? 8. वैसे 6 + 8 × 2, दो ऑक्सीजन है ना, तो टोटल कितना होगा? 22. इसका वैसे कैलकुलेट करेंगे तो 22. सो नंबर ऑफ इलेक्ट्रॉन्स भी सेम है एंड नंबर ऑफ एटम्स भी सेम है. सो देयरफॉर दे आर कॉल्ड एज आइसोस्टर्स. ठीक है, आइसोस्टर्स वेयर नंबर ऑफ एटम्स एंड इलेक्ट्रॉन्स आर सेम, whereas isotones where number of neutrons are same number of neutrons. Isodiaphers where the difference between neutrons and protons are same. Then we have isobars where there is same atomic number but different mass number, same mass number but different atomic number. Isotopes, same atomic number but different mass number, right? So the last two is isoelectronic species. As the name implies, isoelectronic means what? Same number of electrons. Electronic means electrons. So same number of electrons. So you can see here Cl minus has 18 electrons, argon also has 18 electrons. Okay, so both are having 18 and 18 है ना. So Cl का actual number of actual atom number 17 है, but Cl minus बोल रहे means what? वो एक इलेक्ट्रॉन को एक्वायर किया है बाहर से. सो टोटल इलेक्ट्रॉन्स कितने हो जाएंगे इसका? 18 इलेक्ट्रॉन्स हो जाएंगे, राइट. सो आर्गन का ओरिजिनली पहले से एटम नंबर 18 है, तो उसका ओरिजिनली नंबर ऑफ इलेक्ट्रॉन्स पहले से 18 है, राइट. सो आर्गन एंड क्लोरीन. सिमिलरली H2O एंड NH3, इसका भी 10 इलेक्ट्रॉन्स है, इसका भी 10 इलेक्ट्रॉन्स है. BF3 एंड SO2 32 32. सो आइसोइलेक्ट्रॉनिक स्पीसीज इसको बोलते हैं. नेक्स्ट लास्ट टर्म न्यूक्लियर आइसोमर. So what is the meaning of nuclear isomer? Nuclear isomers means are those isomers which have same atom number, same mass number but different radioactive properties. देखिए आपको बताया था radioactive element क्या होता है. Suppose if I am having this cube as a radioactive element, if I am putting here, after half an hour when I come, I may not get the same cube which I kept here. Why? Because this is highly activated. Highly activated in the sense it will try to develop some rays from here, alpha rays, like beta rays, gamma rays. Because these rays when they come out of this, the mass is getting converted into energy and it is getting transferred, because of which what happens now, its size goes on decreasing. What is happening here? The mass which has been decreased has converted into energy, according to our why Einstein is famous for. Einstein is famous for your relation E is equal to mc square. What does this mean? The mass which you are calculating has been converted into the energy. Mass and energy are interconvertible. So the mass which you have kept here, cube, may not be the same when you come after 5 minutes. What has happened? It has been converted into alpha, beta, gamma rays, right? And these rays have some energy. ये energy कहाँ से है rays का? From this mass. Okay. So these kind of elements are actually called as, this kind of substances are called as radioactive substances. रेडियो एक्टिव, हमेशा वो लोग क्या करते हैं? एक्टिव रहते हैं. जब तक मरे नहीं, जब तक जिंदा है तब तक वो एक्टिव रहते हैं. जनरली बोला जाता है कि वो कब तक मरते नहीं, कभी भी मरते नहीं, थोड़ा ना थोड़ा चलता रहता है इन्फिनिट टाइम तक, लेकिन उसका इफेक्ट कम होते रहेगा. जैसे कि यू माइट बी हर्ड अबाउट दिस हिरोशिमा एंड नागासाकी, जहाँ पे न्यूक्लियर वेपन्स डाला गया था. सो वहाँ पे अभी तक ही रेडियोएक्टिव रिएक्शंस चल रहे हैं, बट पहले जितना इंटेंसिटी में चल रहा था, अभी इंटेंसिटी कम है, बट स्टिल इट इज गोइंग ऑन, राइट. सो दिस न्यूक्लियर आइसोमर्स, इन लोगों का क्या डिफरेंट है? इन लोगों का डिफरेंट रेडियोएक्टिव प्रॉपर्टीज है. रेडियोएक्टिव प्रॉपर्टीज क्या होते हैं? एग्जांपल हाफ लाइफ बोलते हैं रेडियोएक्टिव प्रॉपर्टी. व्हाट इज द मीनिंग ऑफ हाफ लाइफ? वेरी सिंपल. आप जो ये सब्सटेंस को यहाँ पे रखे हो, ये सब्सटेंस को आधा होने के लिए, क्या होने के लिए? आधा होने के लिए जितना भी टाइम लगता है, दैट इज रिफर्ड एज हाफ लाइफ. मान लीजिए इसको आधा होने के लिए 10 घंटा लगा. कितना घंटा लगा? 10 घंटा. इसको हम लोग बोलते हैं टी हाफ, रिप्रेजेंटेड एज टी हाफ, हाफ लाइफ. ठीक है. अगर 10 घंटा लगा, 10 आवर्स, तो इसका वो हो जाएगा हाफ लाइफ रेट. समझ गए? सो दिस इज कॉल्ड एज न्यूक्लियर आइसोमर. यहाँ पे देखिए उरानियम इज एक्स, उरानियम एक्स एंड जेड. उरानियम एक्स का हाफ लाइफ 1.4 मिनट्स, उरानियम जेड का हाफ लाइफ 6.7 आवर्स, है ना. सो बिकॉज हाफ लाइफ्स अलग हैं, यहाँ पे देखिए हाफ लाइफ्स अलग हैं, तो इस चक्कर में आपका क्या हो रहा है गाइस? आपका ये न्यूक्लियर आइसोमर बन जा रहा है. हाफ लाइफ मतलब क्या? आधा होने के लिए. सब तो एक ग्रेड में नहीं होते हैं, कुछ लोग जल्दी हो जाते हैं, कुछ लोग धीरे होते हैं. इसलिए जो जल्दी हो जाते हैं, जो ज़्यादा रिएक्टिव होते हैं, जल्दी हो जाते हैं, जल्दी आधा हो जाते हैं, बिकॉज जल्दी वहाँ से अल्फा बीटा गामा रेस निकलते जाते हैं. अंडरस्टूड? सो दिस इज अबाउट न्यूक्लियर आइसोमर. तो हमने क्या क्या पढ़ा, एक बार रिविजन कर लेते हैं इसमें पीछे से ही. न्यूक्लियर आइसोमर आर दोज आइसोमर्स which have all same atom number and same mass number but different radioactive properties, just like half life. Half life is a radioactive property. What is half life? The time taken for the substance to convert into half of its initial value. The time taken for the substance to convert into initial of half of its initial value. ठीक है. हाफ लाइफ का डेफिनेशन, आधा होने के लिए जितना टाइम लगता है. ठीक है. यहाँ पे देखिए अलग है, इसलिए दोनों क्या बन गए? यूरेनियम एक्स एंड यूरेनियम जेड आपका क्या बन गए? न्यूक्लियर आइसोमर्स बन गए. वैसे कमिंग टू आइसोइलेक्ट्रॉनिक स्पीसीज. आइसोइलेक्ट्रॉनिक स्पीसीज इज दैट स्पीसीज व्हिच हैज सेम नंबर ऑफ इलेक्ट्रॉन्स. सेम नंबर ऑफ इलेक्ट्रॉन्स आप कैलकुलेट करना जानते हो, जैसे कि Cl माइनस एंड Ar 18 इसलिए दे आर आइसोइलेक्ट्रॉनिक. देन आइसोस्टर्स, जहाँ पे सेम नंबर ऑफ एटम्स एंड इलेक्ट्रॉन्स मिलेंगे. मॉलिक्यूल्स, ऐसा मॉलिक्यूल्स, इसमें CO2 3 एटम है, N2 इसमें भी 3 एटम है. यहाँ पे 1 कार्बन 2 ऑक्सीजन का एटम है, N2 में 2 नाइट्रोजन 1 ऑक्सीजन का एटम है. ठीक है. टोटल 3 नंबर ऑफ इलेक्ट्रॉन्स कैलकुलेट करेंगे, सेम आएगा. एटम सेम है एंड नंबर ऑफ इलेक्ट्रॉन्स भी सेम है, ठीक है, दे आर कॉल्ड एज आइसोस्टर्स। आइसोटोन्स एज अ नेम इंप्लाइज n सेम नंबर ऑफ न्यूट्रॉन्स। इस केस में देखिए ट्रिटियम में n इज इक्वल टू 2, हीलियम में भी n इज इक्वल टू 2, पोटेशियम में n इज इक्वल टू 20, कैल्शियम में भी n इज इक्वल टू 20, इसलिए उन लोग को आइसोटोन्स बोलते हैं। आइसोडायफर्स, यहाँ पे सेम डिफरेंस ऑफ द नंबर ऑफ न्यूट्रॉन्स एंड प्रोटॉन्स, प्रोटॉन्स एंड न्यूट्रॉन्स का डिफरेंस सेम है। आप अगर कंपेयर करेंगे इसका n माइनस पी इक्वल टू 1, इसका भी n माइनस पी इक्वल टू 1, नाइट्रोजन का n माइनस पी इक्वल टू 1, फ्लोरीन का भी n माइनस पी इक्वल टू 1, ठीक है, डिफरेंस जो है वो सेम है। आइसोबार्स में सेम एटॉमिक नंबर, सेम मास नंबर बट डिफरेंट एटॉमिक नंबर, ठीक है, जैसे कि हाइड्रोजन 1h3, हीलियम 2h3, He3, तो यहाँ पे 3 सेम है लेकिन 1 2 अलग हो गया है ना। एंड फाइनली वी हैड आइसोटोप्स, आइसोटोप्स मतलब सेम एटॉमिक नंबर बट डिफरेंट मास नंबर, क्लोरीन का हो गया, हाइड्रोजन का भी है और कार्बन का भी है, ठीक है। सो दीज आर द important points or important terms related to our atoms. Okay, thank you for your attentive hearing.